Welcome to Classwork 10.1. Today we're starting our calculus prep, so let's get right into it. One of the most important concepts we did this year that will relate to calculus is going to be limits. That's why we're starting here today. So I got to do a quick refresher with you. So we'll do these really quick. It says find the given limits, and we're going to be looking at this picture right here. So look at A. Find the limit of the function as x goes to negative infinity. So just recall that means we're going far left. So imagine this is going to the left forever. Okay, so this thing go left forever. So where are we going? We're approaching 0. Answer is 0. Now if you're wondering how I did that, remember the basic idea of a limit. This means as x approaches a f of x or y approaches k. So it's all about this word approach. Okay, as x approaches a, y approaches your other value, and that's going to be your answer, right? So this k value is what we're looking for. So let's try a couple more. X approaches infinity. What's the limit of f of x? So that means go right forever. So notice how we're going down forever. So that's going to be negative infinity. Negative 2 minus. Hopefully you remember this. As x approaches negative 2 minus, that means approach negative 2 from the left, or the negative side. So go to negative 2, that's right here. Approach it from the left. Look at the y value. We're approaching 1. Okay, so the other one must be approach it from the right. So approach it from the right. Look at that. We're approaching negative 1. Now look at this one. Approach negative 2. This would mean both directions. And look at our answers here. From the left approaches 1. From the right approaches negative 1. They don't match. The limit does not exist. Next one, approach 3 from the left. So we're approaching 3. That's going to be 2. Approach 3 from the right. That's also 2. So approach 3 from both directions must be 2. Okay, so there's our quick refresher on what we covered on limits earlier in the class. Now I'm going to do a couple of examples here. Notice this one. Limit of arcsecant of this expression, x goes to infinity. So I want you to remember a couple things. We're going to infinity. Arcsecant just means secant inverse. And hopefully you remember, if you're going to infinity and it's rational like this, because we're going to infinity, the parts after the leading term are insignificant. So you cross them out. So you're left with 2x squared over x squared. And the reason for that is because imagine you have 2 times infinity squared plus 3 times infinity plus 4. This initial part is huge. It's so big that these parts really don't even matter. And now we're going to do some algebra. Let's cross out that x squared. And look at that. The limit as x approaches infinity, this whole thing reduces down to secant inverse of 2. So think about where secant hits 2. That would be pi over 3. There's your limit. Next one. Compute the limit as x approaches 2 from the right of x minus 1 over x minus 2. Now, you might remember this. We call this the brute force method. And notice a couple things here. If you plug in 2, we get 1 over 0, meaning you have a non-zero over 0. In this case, the limit is going to become, so when you use brute force, this happens, it's going to become plus or minus infinity, one of those things. We just got to figure out which one. So we're going to plug in a number very close to 2 on the right side. So imagine here's our dot. Think of a number very close to 2 on the right, like 2.001. So we're going to plug that in. Limit x approaches 2 from the right, 2.001. This becomes the limit. X approaches 2 from the right. Oh, don't forget your minus 1 at the top. That's 1.001 over 0.001. And look at that. You have a number over a very small number. This is going to approach positive infinity. So when you divide by 0.001, it might help to think of it as like 1 over 1,000. So that's going to become a really, really big number. Okay, next one. Compute the limit as x approaches 1 over x cubed minus 1, x squared minus 1. So you could use a brute force method here, but notice how it's not one-sided, right? The brute force method is really good for one-sided limits. One-sided. But also, we want to have this situation happen, non-zero over 0. So let's look at this example. Compute the limit as x approaches 1 of x cubed minus 1 over x squared minus 1. First, notice that if you plug in 1, you get 0 over 0. That's interesting. Now, hopefully you remember a little bit. 0 over 0, we call that indeterminate form. When that happens, you must simplify. So let's see what happens here. Limit x approaches 1. We factor x cubed minus 1. That's just x minus 1. X squared plus x plus 1. All divided by x minus 1, x plus 1. If I simplify, look what happens. The thing that's creating the issue is gone. Limit as x approaches 1. Now I have this expression, x squared plus x plus 1 over x plus 1. Now I can simply plug 1 in. So you get 3 over 2. And look at that. We have the limit. Okay, 2 more examples. Compute this limit. So I want you to see how it's actually quite similar to our last example. If you were to plug in 3, you get 0 over 0. That's your indeterminate form, so we must simplify. Again, we must simplify this. So what we're going to do is use the conjugate. So this is going to be our conjugate method. Very, very useful method whenever you have radicals like this. So I'm going to simplify it. X plus 1 minus 2 over x minus 3. Multiply by the conjugate to top and bottom. Let's see what happens. Notice the top, you get x plus 1 minus 4. Now the bottom, we're going to leave it like this. X minus 3, the root of x plus 1 plus 2. You don't want to multiply that out, because look what happens here. The top becomes x plus 1 minus 4, which is simply x minus 3, which means I can simplify that. The x minus 3's cancel, and now look at that. We have the limit as x approaches 3 of 1 over the root x plus 1 plus 2. I can plug 3 into that. So that's going to be 1 over the root of 4 plus 2. Look at that. That's 1 over 4. That's the answer. Now our last one. Compute this limit of this trig expression. So we've got to use some trig now. Luckily, we've been doing trig the whole quarter, so we should be pretty comfortable working with it. I also want you to notice if you plug in 0, you do get 0 over 0 here. So this one is also, we got to simplify this thing. So before we start working with it, notice I put this box here, you're a new friend. I'm going to separate this. When you take calculus next year, you're going to be using this particular, some people call it an identity. It's kind of similar in the idea that it is something you're going to have to remember and use as a tool. It's that the limit as x approaches 0 of sine x over x equals 1. That's something you're going to use a lot in limits, and it's something that's going to be very, very helpful for you when you're evaluating any trig limit, especially when you have to use identities. Now I want to generalize this. We're going to write the limit as box approaches 0 of sine box over box equals 1. That's what I want you to box. Or 3D box, I should say. This is going to be super helpful to you as you apply your trig concepts to limits now. So for this one, hopefully your instincts kick in for trig identities. We're going to need the conjugate again. So I'm going to use the conjugate. So I'm going to write 1 minus cosine x over x squared multiplied by 1 plus cosine x over 1 plus cosine x. So notice how it kind of looks like an identity. Now I have 1 minus cosine squared x over x squared 1 plus cosine x. I'm going to move these up a little bit. So all we're doing right now is we're just simplifying. And then hopefully remember your trig. This is sine squared. So now look at our new limit. What we're trying to find is the limit as x approaches 0 of sine squared x over x squared times 1 plus cosine x. What I'm going to do is rewrite this a little bit for you. Let's think of sine squared x as sine x times sine x. Let's think of x squared as x times x. And we do that because now we can use our friend, our identity over there. Sine x over x, sine x over x. So these, because we're approaching 0, become 1. So now I have the limit as x approaches 0 over 1 plus cosine x. And now plug in 0, you get 1 over 2. Done. Now the whole idea for today is a whole bunch of techniques for solving limits, and for this trig one, this idea of your new friend. This is going to be super, super helpful for you. So everyone put a big star in this. Important. You will need this.